Thanks for watching my video today. Let's integrate another integral. Then is in the integral from 0 to 1 of x to the a minus 1 upon log x. Okay, dx is log of 1 plus a, where a is greater than 0. Okay, or a is greater than or equal to 0. Same thing. Okay, a is greater than or equal to 0. So in order to prove this integral, we are going to use the that we call the Feymann technique. Okay, Feymann technique. So okay, let's get started. Now let our integral to be I. So here we put the parameter a, right? So I of a is equal to integral from 0 to 1 x to the a minus 1 upon log x dx. Now I'm going to use that Leibniz rule. Okay, then is according to Leibniz rule, differentiation of a of this one f of ax dx is nothing but this. If you put this differentiation under the integral sign, there it will be the partial derivative. Okay, the partial derivative, that is what we call the Leibniz rule. Okay? According to Leibniz rule. So now here we have parameter a, so let's differentiate with respect to a. Okay, Feymann technique is actually we are going to use a parameter. Okay, so here we choose the parameter to be a, right? So differentiate with respect to a, we have I prime of a. I prime of a mean differentiation of I of a with respect to a. Okay, then is the meaning, and integral from 0 to 1 over log x and partial derivative, right? If you put under the integral sign, it will be the partial derivative. Partial derivative of x to the a minus 1 dx with respect to a. Okay, and we are going to note that the differentiation of a to the x, where a is constant, is nothing but a to the x times log a. Okay, then this is very useful. Okay, so I prime of a is integral from 0 to 1. Derivative of x to the a is something like this. Okay, x to the a log x upon log x, and differentiation of 1 is just 0, right? And dx, and this log and this log will get cancelled out now, so you get integral from 0 to 1 x to the a dx only, right? Then it's very nice. Okay, because this log and log will cancel out, and this is easy to integrate, right? So I prime of s, integration of x to the a is x to the a plus 1 upon a plus 1, right? From 0 to 1, which is 1 over a plus 1. This is what we get. Okay, now this is nothing but the derivative of or original integral, right? The derivative of original integral is 1 over a plus 1, but what we are trying to find out is this one. Okay, this or original integral. So in order to get this back, what Feymann do is that it integrating again. Okay, integrate this again, right? Here we differentiate, right, with respect to the parameter, and we get the result. And then in order to get back the original equation, so we are going to integrate again with respect to that a. Okay, with respect to that parameter. So integration of I prime of a dA is integration of dA upon a plus 1, right? Which is integration of this is nothing but log 1 plus a. Okay, this is indefinite, so don't forget this constancy. Okay, the constancy. So integration of the derivative of I of a is nothing but I of a only. Okay, because integration of dx is what? X only, right? Same way this one. Therefore I of a is nothing but log 1 plus a upon log 1 plus a plus c. Now we are trying to find out c again. I of a is nothing but original integral, right? This one. Now we don't know this constancy, right? We are going to find out here. To find c, now if you put a equal to 0, then here if you put a equal to 0 here, x to the any power is, right, what? Any number to the power 0 is just 1, right? So 1 minus 1 will be 0. That means or I of a is 0, right? Here or I of a is 0. That means let's calculate in here. Or I of a is 0, meaning here this will be 0, right? So 0 equal to, if you put a equal to 0, so you will get log 1, right? Log 1 plus c. We know that log 1 is just 0, right? So it will be c will be 0. Therefore c is 0. Therefore our integral is integral from 0 to 1 x to the a minus 1 upon log x dx is nothing but log 1 plus a. Now the particular case is that if example like integral from 0 to 1 of x minus 1 upon log x dx. Okay, you may wonder how to prove this. This is nothing but or log 2, right? Log 2. Here if you put a equal to 1 only, right? And if you put a equal to 2, 3 and so on, then you'll get this one. So this is how this is an example of Leibniz rule or the Feymann technique, what we call, right?